Hi everyone. Let's wait for a few seconds so that others can join us too. Okay, we have a lot of participants here, so we can formally start. Hello and good morning to everyone present here. We have a very insightful session planned for you all today. Thank you for joining us for the webinar. The title for today's discussion is The Use of Automation for Building a Sustainable Data Warehouse Architecture. Let me quickly introduce the speakers for today's session before I share the agenda for the webinar and we delve right into the discussion. My name is Haris Azim, and I'm the product marketing lead over here at Astera. I will be your host for this webinar today. Then we have our panelists, William and Jay. William is an author, solution expert, and the number one global influencer in big data, data centers, and cloud, and a top influencer for master data management category. Jay is the COO at Astera Software, and he is experienced at developing end-to-end data automation solutions for leading organizations. Over to you guys.
Hi, I'm William McKnight, president of McKnight Consulting Group, and I'm excited to be here talking about one of my favorite topics, which is data warehousing. And we spend a lot of time on it, as we should. And let's talk about it and talk about where we're going with data warehousing in the future. See you soon.
Hello everyone, Jay Mishra here. Been with Astera for a long time. Been part of a lot of implementations for data warehousing solutions. Have seen the growth of this area. Very excited to be here and talk about data warehousing and specifically data warehousing automation.
Thank you guys. It's great to have you both on board today. I'm sure we stand to learn a lot from your experiences and expertise. Okay, so here is the agenda for today. So first we'll be talking about the concept of sustainable data warehousing and why it is important for modern data architectures. We would also be talking about how data warehouse automation can be used to modernize and develop data architectures that are sustainable for the organizations. Finally, we would be having a 15 minutes masterclass to demonstrate how automation can be used to build a sustainable data warehouse, followed by a Q&A. If you have any questions regarding the discussion or demo, type your questions in the chat box and we'll try answering them during Q&A. Um, okay, so let's begin the discussion. So here are a few facts about the state of data warehousing today. According to a global research by Wenson Bourne, 83% of IT decision makers currently across different organizations and verticals are unsatisfied with their data warehousing initiatives. And then according to a survey by Bark, 44% of data architecture and BI users consider lack of agility in development processes to be the biggest challenge in the realm of data management and data warehousing. And similarly, 35% of such users blame restricted self-service BI, which is the absence of automation in data warehouse environment. And given these challenges, 60% of data architecture stakeholders are now approaching modernization using data warehouse and ETL automation. With these facts in retrospect, I'd like to invite our panelists here as well. William, I'll be starting with you. As you know, data architectures and data warehousing technologies have been changing significantly over time. We can see legacy data infrastructures evolving into modern data warehouses supporting, capabilities like parallel processing, native cloud support, data warehouse automation, and all these new data storage and analytics methodologies, coming forward. So, William, tell us something about your experience with data warehouse architectures and how have you seen them grow and evolve over time, particularly?
Okay, great. Thank you for the question. My experience with data warehousing is immense. I've spent my whole career in data and really cut my teeth on data warehousing. For the first like half of my career, it was really all about data warehousing, and it's evolved like data warehousing has evolved. Data warehousing used to be just pretty simple. All right, as we look back, it was simple. Obviously, there was a lot of science put into it. It was novel at the time, but it was bringing data from a source to a target warehouse, remodeling it, maybe cleaning up the quality of the data a bit, and then putting a BI tool or tools on top of that. Maybe you had some marks hanging off the warehouse and so on. Today, is part of an ecosystem. See, we used to think the data warehouse was the be-all, end-all. It was going to collect all data in the enterprise, and it was going to serve up all data needs in the enterprise. And we soon learned that that was really too lofty of a goal. Of course, it's a great goal if you can pull it off, but it just really couldn't be pulled off that well inside an enterprise. So up sprang multiple marts, either before or after the warehouse or completely independent of the warehouse, and on and on and on until we get to where we are today, which is nobody's flushed away their warehouse and said, we don't need it anymore. As a matter of fact, it's still very important, but it sits as part of an ecosystem of artifacts. And so now we've added in things like the data catalog, data science tools, the data lake itself, data visualization, all kinds of things are happening in the data access arena. We'll touch lightly on that today. It's not really part of the backend architecture, but there's a whole world going on right there as well. Data virtualization is part of that. And of course, we're applying DevOps characteristics now to the data warehouse as we are other things within the enterprise. And also there's been a lot of change in terms of the architecture. So obviously we have moved to a lot of cloud storage, and many customers out there, many enterprises are under a cloud mandate. It's cloud first, and they're actively trying to move their on-prem warehouse to the cloud. Now, that being said, there's still going to be a lot on-prem. I'd say probably a good, maybe half of warehouses are still on-prem, and maybe half of those are in process of moving to the cloud. So it's kind of a slow transition, but it's very much there with us. And this is also an opportunity to take a reevaluation of the platform that you're on and make sure it's right, make sure the architecture is right, and so on. Of course, we're kind of limited in what we can do there because we're also under the gun to make things happen. And so I think that not only is the platform changing, but also the architecture is changing. Now we have things called the data fabric and the data mesh, which are decentralized concepts. It's more acknowledging of the situation. Hello? Okay. So the data fabric is a recognition of the decentralization nature of the data warehouse. So now we have bits and pieces of the overall warehouse out there in different business departments and so on. And now we're applying some science behind that, some best practices behind that, which is welcome because that's kind of the situation that we're all in. And of course, the data mesh is an independent concept of data fabric, and that's taking hold as well. And there's been some best practices being applied to that concept, which is really, as I see it, kind of data virtualization on steroids. So it's an acknowledgement that data may exist throughout the enterprise that's needed for what we formerly could just find in the warehouse. And now we know that there are bits and pieces all over the enterprise. And as we move to the cloud, the last trend I'll add is as we move to the cloud, a lot of that is hybrid cloud. And we're not committing to a single cloud as an enterprise, and sometimes not even within a data warehouse architecture. So a lot of change happening in data warehousing, but it's still very important to the enterprise.
Thank you, William, for such an insightful response. I think we can now clearly trace the trajectory of how data warehousing and the related emerging technologies have been evolving to accommodate our, ever-expanding data needs. Jay, would you like to add anything to what William mentioned about this trajectory of data
Definitely.
warehousing?
So let me actually add to what William was talking about earlier about kind of journey of the data warehousing and the state of the art, what we have now. So really three stages. The first stage was early days of data warehousing when from Ralph Kimball guidelines, Bill Inman. So the initial patterns were emerging, and practitioners basically they were implementing data warehouse by doing data modeling. Someone is doing data modeling on their own. Then someone is writing ETL scripts and code to bring data from your sources, do data massaging, and then populate your star schemas and snowflakes and so on and so forth. And everything was hand coded, but still the practitioners they saw the patterns emerging. So You do it once, you do it twice, you do it 3 times, and then you see that, hey, here is something that is in common. So when you're loading into tracks or dimensions, you see that certain things are repeating. So they saw those patterns, and they created their templates, they created their checklists, and that's how most of the solutions were implemented. That is early on. And then came the wave of the ETL products, where you do have some help, but it's an ETL product, it's an ETL toolset. Still, the solution design and implementation is your responsibility. The checklists and the templates were still applicable. You do have some help in mapping and transformations, and the ETL product is being able to go to the source, and maybe the select queries and all that will be automatically built. Writing and the destination will be automatically done. But the rest of implementing the architectural patterns, about the modeling and making sure the right sequence is maintained for inserts and updates, and all those things were still responsibilities of the person who's implementing it, the data architects and the ETL developers. Then came the wave of, I would say that where Astera is right now, is adding automation to it. So if you look at those templates and the checklists, they have been around for over 2 decades now. So, and we saw that there's a way to automate it. So what we essentially did that, we took those templates, those checklists, and automated from the beginning all the way to the end. So data modeling, it happens in our product. The ingestion of data, the automatic query building for joining multiple sources and all that, it happens in our product automatically. The SQL is generated. The transformations automatically generated. And then even the loading of your destination, whether you are using star schemas or you're using data vaults or 3NF or whatever model you choose for your warehouse, we can pick that and we can automatically build the SQL queries internally for you, and the user is working at the GUI level. They're just doing drag and drop maps and all that. And not only that, take the data in your data warehouse or data mart and make it available to the end user, the person who is going to be using it in their reports in Power BI or Tableau or any dashboarding tool. So that is the last mile. So even to delivering data to that last mile, that is the entire journey. And the process, whatever is repetitive, should be automated, and we did automation of that. And that's what we, at least in my opinion, is the current state of art of data warehousing automation. So that's what I would like to add. Over to you, Has.
Well, thank you, Jay. Something like this shift from manual SQL to this automation of entire data warehouse lifecycle seems transformational for enterprise building their own architecture. So, I mean, as we saw in the beginning, and as per my own experiences as well, it is true that, the things you mentioned, data modeling, ingestion, query building, and scripting required for ETL pipeline and general data warehouse maintenance it takes a lot of resources and time. This is where organizations need automation to modernize their architecture. So now, could you tell us something about how automation can contribute towards making your data warehouse architecture more sustainable for current and future data needs?
I believe, William, do you want to go first with this one, or do you want me to?
Well, I could, sure. So, I mean, anything that can be automated probably should be automated. I mean, that's the very essence of artificial intelligence, which is a concept that we're all kind of embracing today. And of course, the first target for a lot of artificial intelligence in the enterprise is, what can we automate around here? Now, the data warehouse is tricky. We're not building widgets here. It's a creative endeavor. It really is. However, some of the more non-creative functional aspects of the data warehouse can be subject to automation. And I think every enterprise owes it to themselves to take a look at that and see if they can't start to finally focus more of their time on some of the artifacts of the enterprise, like machine learning, artificial intelligence, the data lake, and data science in general, so on, that are going to be providing the competitive advantage in the next 5 to 10 years. So if enterprises are behind on that, a lot of times it's because, well, we're short-staffed, and that staff has to work on the data warehouse because that runs our business. Of course it does. But if the data warehouse were built better, maybe we wouldn't have to be supporting it so much. But it is what it is. But these warehouses can be moved into a more automated situation for their upkeep. And so that is something that we're looking at with different enterprises. How can we get it into a more adaptable situation and a more scalable situation, which are the two real pillars of a sustainable data warehouse. And adaptable means that as the business needs change, that the warehouse changes with it. So new columns, new tables, new sources, and so on. We don't go through that IT 30-day, 60-day, 90-day, whatever kind of cycle that it is to get that change happening in production. We just really don't have time for that anymore. And so we need a warehouse that is adaptable that way. We also need a warehouse that is scalable. And I know we kind of know what scalable means. I like to think of it like we don't have to think of there's a magic number out there where when it hits that size of users and definitely data, that we have to have a panic, right? We have to do something manually intervene. I don't want to worry about that. I don't want to have to guess at the beginning how big it's going to get and all that sort of thing. We don't know. My guesses over the years have not been that great, and neither has anybody's as far as I can tell. And so scalability kind of takes that off the table. Cloud data warehouses are almost by definition pretty scalable. So we see a lot moving to the cloud for that reasons. And also, I will add that databases should not get all completely locked into the platform that they're on and adapt all those characteristics, because a lot of data warehouses do change platforms. They change platforms for various reasons. And so they need to be migrated. Sometimes it's not whole cloth the data warehouse moves, but bits and pieces of the warehouse might move to other platforms, and the whole thing still has to work together harmoniously. So when your data warehouse can support a migration like that seamlessly, that is also, I think, part of automation, part of sustainability.
Absolutely. Thanks, William. So I would like to add a couple of points to that. For sustainability, I believe one thing that is of key importance is to have one integrated development environment. So we have seen this thing in the context of data warehousing. With our experience, we have seen that the team needs different tool sets, different functionality. And traditionally, you will have a data modeling tool where you're doing data modeling, and then once you're done, you port it over to your platform. And as you mentioned, sometimes basically you got to be agnostic to the platform. You build a data warehouse, and today you want to do it on Azure, but tomorrow you want to move it to Snowflake. So adaptability, of course, has to be there. And the data modeling tool is one part. Then you have an ETL piece where you're bringing data from your sources, and it has to be, again, adaptable, where you are able to add new sources, new streams, and very quickly. And then, of course, changes to your schema, you have to be able to respond to that very quickly. And then the architecture is a third, I would say, variable, where depending on what you choose today, it may not be the same tomorrow. Let's say that you want to go with star schema today, just a star schema, but tomorrow you want to have, let's say, a raw data vault and data mart sitting at the top of it. So you should be able to adapt to those scenarios, those challenges, those demands, and to have different platforms, different tool sets doing all those different things is not going to be an ideal scenario. Ideally, you want to have one integrated platform that is able to give you all that functionality under one roof, so that you are able to do all that work under one platform, and then the communication issues and all that are not there. So I think, at least from our experience with implementation of hundreds of data warehouses, we have seen that the choice of platform, our choice of toolset makes a difference. And the toolset that is able to give you all the functionality from data modeling to the ETL, data warehousing automation, going all the way to publishing your data for your end users. If it is in one platform, that makes a huge difference. So that is one thing that I would like to mention. And second is, again, coming back to adaptability. That is also very important for sustainability, what we were talking about earlier. That is, you should have a choice to make any combinations work for you. So let's say that today you want to start with a parallel data vault and a star schema dimensions and fact-based warehouse. And then later you decide that, okay, hey, I want to have I want to have the data vault and put a data mart at the top of it, have them talk to each other. So all those modeling techniques and all that, they should be available to you, and you should be able to use them as and when you need. So adaptability in terms of architectures as well. To implement those architectures at will, that also makes a difference. Because in modern times, it is not that you pick one modeling strategy and you're going to stick to it forever. These things change quickly. So being able to switch from different architectures or have them talk to each other is very important.
Well, that makes perfect sense. Thank you, Jay and William, for helping us conceptualize sustainable data warehousing. I believe it is really important to understand that scalability and agility in your development processes and outcomes are, central to having a sustainable data warehouse architecture. And as you mentioned, Jay, having an integrated data architecture and an adaptable design architecture, in addition to what William mentioned about needing an adaptable schema, a scalable architecture, and a platform agnostic architecture, like that's how I construe it as well, where you can easily migrate or to switch to different databases or cloud platforms. It's important for building or modernizing a data warehouse architecture. Having automation in place ensures that you have the flexibility to do all of this without having to expend resources on complex development. With this in retrospect, coming to you, William, what could be some of the benefits business and technical users can derive from using automation?
There are many ways to kind of look at the return on investment of automation, but it's there. It's pretty straightforward to do it by just looking at a total cost of the operation, right? TCO. And so what is it costing you to do it your way, the manual way, the way you've been doing it, versus what it would cost you to do it in a different way that we are calling automated, because it's a whole lot less than that, right? So that's one way. There are labor savings in there, but of course there's that. You gotta bring yourself as an enterprise to that work effort to actually get it over to that. So that has to be factored in as well. And of course, we can do that as well. Now, I think I was just reflecting on some of the reasons why I've seen enterprises move to a different platform, either automated or not. And they're actually many and diverse, and it's very particular to the enterprise. So I've seen enterprises move off parts of their data warehouse because the warehouse they were on didn't have good graph capabilities. And rather than invest in a graph database, they're going to try that workload out on a database that has some inherent graph capabilities. Same with if a database is not a great columnar database, which we all know now is the ideal way to arrange a data warehouse or any kind of analytical database. So if you don't have good, strong columnar capabilities, then that's another reason why you might want to move off. Another reason is now that we're accumulating a lot of data over years and years, just strictly for costs, keeping that data, we want to keep it alive, we want to keep it all active, but it doesn't necessarily all have to be on so-called hot storage where we can get random access really quickly off that data. So if the database itself is smart about moving that data around behind the scenes to different layers of storage that maybe provide some hot, cold kinds of characteristics on that data, there can be a cost savings just inherent right in that. A lot of times it does come down to cost savings as these data warehouses grow bigger and bigger. These are great opportunities to look at automation. And not only can you add in the cost of making the leap and then the reduced cost of upkeep, but what else can be done with the resource time that you now have as an enterprise, now that you are freeing that resource up around manual tasks of the data warehouse, which we just heard was about 80% of it. So, I mean, that's more than I thought, but that's a lot. It's something that clearly is sitting out there as a prime target to prime target opportunity. And when you have tools like what we're talking about here today available to you, I mean, I just think it makes sense to have a look at that and make sure that you are treating the warehouse with the utmost respect that it requires. And what Astera does, for example, is it abstracts you from a lot of the details and still allows you to carry on for most of the things that you're going to want to carry on with in a data warehouse. So that's how I would go about valuing data warehouse automation.
Thank you, William. Anything you'd like to add, Jay?
Uh, Definitely. Just one point about the automation in data warehousing. The way we look at automation is that anything that you do once or twice or three times, we know that there is a pattern in there. And we have taken pretty much everything that is out there in data warehousing, from data modeling all the way to publishing of your data warehouse to the user. We have looked at the entire life cycle and looked at all repetitive tasks and created automation on it. So of course you configure it once, but after that, we take care of the rest. And this includes basically the data validations, data quality checks, and not only that, let's say that you publish your data warehouse and for some reason the data integrity is not there. So we have options to even check that. It'll go and check and verify and say that, okay, hey, here is your facts and dimensions, they're not in sync. So even going to that level, we have added automation. So the idea is that over the years, this community of data warehousing experts, we have seen patterns, we have built patterns, and those patterns were implemented manually. What we have done is we have taken all those patterns and automated them. So as a result, you're getting the same work done, but that is being done automatically for you. As a result, what happens is that the amount of time you spend in doing this has gone down significantly. And therefore, agility. You have ability to do those things that used to take months, sometimes weeks, definitely. Now it is down to number of just a few hours, and that by itself is induces basically a behavioral modification. Now we're talking about, we don't think about data warehousing as, hey, it's going to take a few months and before you see any results. Now you are able to do the experiments. You are able to go about it in a few hours and say, okay, hey, how it looks like. This is how my data looks like. If I'm okay with this, or I want to try out something else. So this whole behavioral modification happens only because what we have done is we have taken automation to that level where the amount of work that was required to see the first result has gone down significantly. So that's how we approach the entire data warehousing automation. We have added nothing new here. We have taken exactly the existing patterns that have been established for years and automated them. So that's how we look at data warehousing automation. And in future, I believe, and actually we are already working on it, to use even artificial intelligence to automate certain other aspects of it, where we can automatically recommend that, okay, hey, how about picking this entity as your fact or your dimension, or you're dealing with data vaults, how do you handle with your hubs and satellites and links and so on and so forth. So that is where I believe we are going as the next stage of data automation, where we'll be using a lot more of recommendations automatically coming to the user.
Thank you, William and Jay, for sharing these benefits. It's pretty clear now that through automation we can cut down the design and development lifecycle, or the time expended in maintaining and updating the data warehouse, significantly. A key statistic to quote here, as William also briefly mentioned, is that 80% of the life cycle's time is spent on doing repetitive development tasks or writing manual scripts for design, development, and maintenance of a data architecture. And now we can imagine how we can save 80% of this, 80% of the development life cycle time through automation, and use it probably elsewhere for acting upon the actionable insights or intelligence we derive from our data. We can now also see how, equipped with the data architecture and automation tool, organizations can truly empower their businesses and IT teams to collaborate and work on data architectures in a much more agile and sustainable method. All right, so this concludes our discussion on sustainable data warehousing and the use of automation in it. I think it is time for us to move to a masterclass in which Jay would be demonstrating the use of an end-to-end data warehouse automation tool. Jay, if you'd like to take over, please.
Excellent. Well, thank you. All right, so we have about 15 to 20 minutes to go through this presentation. And I would like to first start with giving you with an overview of what we're going to see. So what we're going to see is that how we take a very simple, I would say, standard data warehouse solution being built. Scenario is that we have two data streams, that is two data sources. First one is a production database that contains information about our sales and invoices and so on and so forth. But we do have a CRM system that contains information about our customers, and that also needs to be brought into the data warehouse. Of course, we can have multiple sources, but in this case, we choose only two sources. So we bring in the data from the two sources onto one staging area, and from there, we populate our star schema data warehouse. So we will start with the data modeling of the sources, and then how we populate our staging area with all the sources, that is combined data from the two sources, and then staging area, how it helps us doing automation of loading into a data warehouse. And once we have the data warehouse populated, we will see how we can fetch data from the data warehouse all the way to a Microsoft Power BI dashboard. That's what we are going to be seeing. So starting with the first step is to build the data models. So I have been talking about data modeling from the beginning of this conversation. The data models form the core, or I would say the centerpiece of the design of data warehousing automation. Once the data modeling is done properly, it paves the way for automation. And traditionally, people have been spending a lot of time on data modeling. There were popular tools like Irwin and others. We have our own built-in data modeler that is equipped with reverse engineering and forward engineering and full data modeling functionality. And the data modeling that is specific to data modeling architectures for data warehousing, such as if you want to deal with star schemas, that is Kimball style modeling of facts and dimensions, or you want to deal with, or you want to work with a 3NF model, just the entity relation, ER models, or you want to create a data vault 2.0 or 1.0, where you have your satellites and hubs and links and so on and so forth. So, irrespective of the architecture you choose, you can do all the modeling in our product. So let's start with the first one. This is the source. So I have a data model that is a source model, relatively simpler model. It has about 10, 11 entities. And let me zoom in a little bit. So you can see that we have invoices, orders as entities, a purely relational data model that is showing us how the tables are created and connected to each other in our production database. This is our sales production database. And the way it is created is by pointing to the database. You simply point to the database and whatever provider it is, say it is SQL Server or Amazon Redshift and SQL Azure, wherever Amazon Redshift, wherever your data resides, you can point to that. And you can do reverse engineering. It will show you all the entities and click on OK, and it will build the data model for you automatically. You can, of course, modify and enrich the data model if you need to. The lines between the entities, they show the relationships among the entities and so on and so forth. So this is our source model. Now we have another source that is our CRM system, from where we are pulling data using APIs. We have REST APIs for the CRM system, and we want to pull data from that. So that is our second source. So once the two sources are combined, we get a staging layer. And this contains now a little bit more than what we had in our production database. It has a couple more entities coming from the CRM system. So now this one is a combination of the two sources. It has 10 entities coming from your production database and a couple more entities coming from your CRM system. So this is basically a union of all the entities coming from the two places. So let's say you had a 3 or 4 or any number of sources, all those entities will come together in this place. So this now forms the basis of automation for loading into your data warehouse. So in this case, we have chosen a simple star schema. So star schema modeled already. You can see that actually this is the full star schema where we have a couple of facts, that is order and sales, and dimensions such as the customers, the employees, the date dimension, the location, that is the city, and the stock items, and so on and so forth. And the couple of facts are sale and order. A couple of views. The first view is just order centric, and second one is the sales centric. So let's have a quick look at sales centric view of the star schema. The fact is sale, and we have customers, employees, stock items, cities, and date as being the dimensions for this specific fact. So I was talking about earlier, you can build the models, and you have to enrich it, and you have to make sure that they have all the information that is required to automate the pipelines that will be loading the star schema. So let's say that in this scenario, my sale is connected to customers, and let's have a quick look at the customers and see that how one can configure the dimensions and facts. So here is my dimension table, and customers, it has about 20 columns or so, and actually 17 columns. And you can see that the dimension role is configured. And for some of the items, we are using SCD2. So when we're dealing with historical data and dimensions, it's very tricky to handle these SCDs, SCD1, 2, 3, and 6, and so on and so forth. What we have done is, as a user, you don't need to worry about how to handle that internally using SQL and all that. What you do instead is, in the GUI, in the data modeler, you come to the entity that is the dimension entity, and you assign the role or assign the handling of dimension for that specific field. So in this scenario, we have the discount percent is going to be a CD2. Our credit limit is going to be a CD2, whereas others, such as the phone number, fax number, website URL, they don't need to be inserted and updated. They just need to be updated. One record is good enough. So that is SCD1. And others, we have surrogate keys, effective dates, expiration date, business keys, and so on and so forth. So when you look at these field roles, dimension roles, you can see that these are standard patterns. This is the patterns I was talking about earlier. They have been around for decades. People know that how to use SCD1s and 2 and 3 and 6. And of course, it is evolving, but we keep adding to this list. And here you configure in one place what is the role of each of these fields and entities. And basically, this is how the entire model is configured. Now, once the model is configured, I click on this verify button. And this verify, what it does that, it goes through over 2,000 built-in verifications for checking whether your data modeling has been done correctly based on standard practices or not. And that's a huge deal. This is where people used to spend several days, months, sometimes a week, sometimes months, to make sure that it is done properly. If you make a mistake, you're going to see that the result is not going to be good. So here, beforehand, you are able to verify and make sure that whatever work you have done so far, it is based on standard practices. And the checklist I was talking about earlier, that checklist is verified automatically for you. So now your modeling is done, your source is modeled, your destination is modeled. Now the next step is to build the pipelines. Let's have a quick look. So first one is source to staging. So let's say that you're loading a simple data, let's say customers, going into your customers table in the staging. Now customers, as I explained earlier, is a combination of two entities, one coming from your production database and one is an API call. So here, what you're doing is this API call, customer CRM API call, is actually going to get a JSON object by fetching the data from your API call. So it automatically parses that and combines the data with the database table information that you have about customers, joins that, creates the unified data set, and that is what is populated inside your staging. If you go to something simpler, such as stock item, that's simple database table to database table move. If you go to others, so depending on the need, the point is that depending on the need, you can build these pipelines, and that's what is loading data into your staging area. So once the staging is done, let's have a look at the pipeline for loading into the data warehouse that we have just looked at, that has a couple of facts and multiple dimensions. Now, how do we load into that? So I'm going to pull a couple of samples. The first sample is loading into the fact tables, the sale and orders, and the data is coming from the entire staging database. And the data could be coming from multiple tables. Indeed, in the case of the orders, it is coming from multiple tables, actually 3 tables, and you're mapping to the user. This is how it looks like. It has 2 boxes, left and right. Left-hand side is given the entire data model as a source. So here you can see that since we have the information about the data model, we can automatically build the tree structure that is connecting the parents to children, to grandchildren, and so on and so forth. So since we can traverse the entire database, we are able to build the relationships and give you this model from which you simply drag and drop. You don't need to worry about how to build the joins and how they're connected to each other. All what you care about is that, hey, the first 4 fields are coming from order lines. That is order ID, quantity, unit price, and stock item. You map them into 4 fields, in fact. Next 4 items are coming from a child table, that is order, and that is the order date, the customer ID, and so on and so forth. Another field is actually coming from a 3rd table that is actually 3 levels down from a customer table, and I want to get the postal city ID. That's what is going to go into city ID. So irrespective of wherever your fields reside among, in different tables, you can simply expand it and keep traversing to whatever level you want to go to and pick your field and simply drag and drop onto the destination. So that's how simple the interface becomes if you have the source modeling done. So that's what the source model is helping us with, giving us this automation to pick and choose simply and map it onto the designer, onto the destination. Destination is a fact, and facts, you know that when you are dealing with the star schema, loading into facts is not straightforward. Any field that goes into fact has to be looked up from the corresponding dimension, get the surrogate key of that, and get the right record, by the way, if it is historical data. And that lookup has to happen before you can populate your facts. So to the user, you simply map into the field. But since we know that this is what your data model is on destination side, and by the way, if you go to the properties, we show that this is the data model, this is where it is located. So we know that what are the data models on the source and destination side, and we use that data model to automate all the things behind the scene for you. So in this scenario, building all the SQL joins for you, getting the SQL query to load the data from the source, and then on the destination side, how to do all the lookups from the dimensions, get the right row from the dimension, get the surrogate key from there, and then populate that inside your fact. All of that work will be automated. Let's go ahead and actually hit on run button to see the job running. So I just ran this job that is populating the 2 facts, the sale and orders fact. Both of them equally complicated. We are talking about joining data from multiple tables and writing into the facts where we have 6 or 7 dimensions on each of them. So it has to do all that work and create the native SQL for my platform. In this case, my native platform is Microsoft SQL Azure. You can pick and choose any. You can have Snowflake, you can have Amazon, you can have Google, whatever platform you choose. So we had about 500,000 records. The processing is done, all in green, no errors. And it took about 28 seconds to complete this entire work. Now let's have a quick look at actually the SQL that was run on the underlying platform. And you have, you can actually verify it, review it. So here is the SQL. I'm going to go ahead and click on open. And there we go. We have, let me just minimize this so that we can have a full screen. So there we go. So this is the, actually, you can see here, this all the SQL. Very complicated SQL, about 110 lines, is equivalent to basically what you're seeing this mapping here. So this mapping is the mapping that is the user is seeing, or the user is performing the mapping. And this is the SQL that is actually running underneath, running on the engine. So this SQL actually represents all of that. And you can verify that by looking at this, all the left outer joins that it is doing to do the calculations or doing the lookups on the dimensions and using the logic that you have applied inside the data modeling stage. In data modeling stage, you have configured the facts and dimensions and based on which it is building the SQL. So any pattern that you have in your mind or that is required for your solution, you configure that in the UI, and we will automatically build the native SQL and will push down to the underlying platform. So that's what I would say the key message here is, that the user is dealing with the simple graphical interface where you're dealing with the simple drag and drop maps and all the complexities of reading, transforming, and loading into your data warehouse. And irrespective of, by the way, architectural patterns, you are using star schema, data vaults, 3NF, it does not matter. One big table, if you want, you can do that too. Whatever you choose, we're able to load data into that and build the native SQL query for you. So that's how basically the flow works. And now we have loaded the data. All 500,000 records are in there. What happens that this data model now is automatically deployed as an OData service, and it is available to be consumed by your end users. So since it is already deployed and data is already available in my facts and dimensions, I have already built a dashboard in Microsoft Power BI, and that is actually this nice looking dashboard here. Orders per day, sales per month, count of orders per city, orders per employee. You can see all your tables on the right hand side from our models, that is orders and employees and date dimension and customer and so on and so forth. So this is the data warehouses. This is built at the top of that data warehouse, picking all that data and building all these reports. These are, of course, based on the timeline per day, per month, and so on and so forth. And it just got populated, and this is the data that we are seeing. So this is the end to end. From the beginning, you go to the source, do the data modeling. You're able to automatically build the pipelines to populate your architecture of your choice and then publish that data to your end user to be used in a dashboard like this. So that's how basically the end-to-end solution for Astera Data Warehouse Builder works. It does automate all the repetitive tasks and takes care of all the best practices automatically for you. So that is it from my side. I think we are in time for Q&A. So over to you, Harris.
Thank you, Jay, for showing us some of the major technical aspects of sustainable data warehouse development and how an end-to-end automation platform like Astera DW Builder can streamline those. I mean, I can see how with a tool like this, we can automate most of the complex parts of the entire data pipelines, especially those related to data warehousing and BI. It was remarkable to match this automation with the actual complex SQL coding needed to develop or maintain a data warehouse. I mean, the flexibility and the adaptability of supporting all these different architecture patterns is what makes your data warehouse actually agile and sustainable. I'm sure that answers a lot of questions with respect to how automation tools like Astera DW Builder work. Now, I'm sure our viewers have other questions for our panelists as well. I'm opening the floor to Q&A session now. Uh, okay, so we have started receiving the questions. All right. So the first question, I'll read it out. So the first question is that you mentioned different types of sources. Does the tool offer something like change data capture or real-time data ingestion for all these sources?
Absolutely. I'll be happy to take this one. So CDC, of course, I did not get a chance to talk about it, but this is something that is a key ingredient for any data warehousing solution. If you don't have CDC, you are basically loading the entire data warehouse every time. So change data capture is something that is of utmost importance, and we have built CDC functionality that is native to most of our providers, most of our database providers, the sources from which the data is coming. So SQL Server, Oracle, MySQL, Postgres, to name a few, they all have built-in CDC. So, and we have different ways to implement CDC. We have one CDC that is based on some column inside the database itself. If it is not there, we have a way to record actually create a log of all the entries and use that log to implement the CDC. So we have it built for all the major providers.
Okay, so we have a follow-up question. So with all the different data modeling techniques at our disposal, which one out of these do you think would sustain in the near future? Yeah.
So in my opinion, I think By far, the most common one still to date is Kimball style modeling. Still is very, very popular, but we do see quite a bit of data vault as well. And in a lot of our implementations, we see that it's a combination. It's not just either or. It's a combination of data vault and maybe star schema sitting on the top of it or side by side. So depending on the need, I think they're going to coexist. One is not going to go away because these are solutions catering to specific needs, and those needs are not going to go away anywhere. And these are great solutions. They're going to coexist and well into future. William, would you like to add anything to that?
Yeah, I mean, I think the future is probably schema-less, and I don't see a lot of innovation that's going to be happening in the modeling for data warehouses. Third normal form, dimensional modeling, you can get there from here. Either way. Some ways are going to be some things are going to be hard to do depending upon your modeling technique. That's why some organizations have multiple, maybe dimensional modeling in their marts and whatnot. But I don't think there's going to be a lot of innovation now. This person particularly calls out the ODS. I think we're done with that. I'm not coding a lot of ODSs out there anymore. I think we know that we can pass the data into the warehouse quickly enough to meet the needs of what the ODS met before. Yeah, there's some data vaults going on, mostly in Europe. Okay, I just don't think there's going to be a lot more innovation in that. I think the attention of enterprises is going somewhere else and going into artificial intelligence, going into all data, going into a schemaless kind of data lake kind of model down the road. And data warehouses for the I like to call it the actionable future. You still have to do everything on them that you've been doing, and they are still absolutely critical. So it depends upon what time frame you're talking about in terms of what will sustain eventually. Eventually, I don't think we're going to need multiple copies of data in the enterprise. We're going to be able to glean out whatever value, whatever historical data that we need from every transaction in a highly compressed format. And I don't even think we'll need to be storing all this data. We'll just get the compressed format out that we need in order to do business and go forward. And artificial intelligence will kind of take over looking at everything and doing the right thing and possibly even running the company at some point. But anyway.
Amazing. We have another question from you, William. So, William, so it says that William, you talked about the evolution of data warehousing in detail. You talked about how currently enterprises need a sustainable data warehouse architecture, which makes a lot of sense. But in your view, what is the future of data architectures from here on out?
Yeah, I kind of just talked about that a bit. In terms of data architecture, I think we're going to be in this struggle for the next several years. I see enterprises in this struggle. We want to get it architected, but we got to do this other thing, and we got to push forward into data lakes and other forms of analytic stores that we don't have. And so, shoring up what we do have, while it pays for itself and it's pretty obvious, and it moves things into a more automated arena. We're still distracted by the need to push forward on other things. And I totally get that. But I think that's going to be kind of a dilemma that we're all going to be in for the rest of our data careers, for sure. And the way I see it now is data architecture, it's going to get more complicated before it gets less complicated, before we kind of figure it all out and kind of maybe figure out something, not the data warehouse, but kind of the evolution of the data warehouse that meets all needs of the future. I think, it's just going to be more complicated. So if you find yourself in an enterprise in a complicated architecture, and why are we doing things this way? Probably you're not that different from others. Not saying you don't need to move that forward. You absolutely do need to get it into a more architected approach, I'm pretty sure. But that's kind of the way of things. It's kind of because we're clamoring all over data, trying to become data driven, and moving so fast that we can't slow down.
Awesome. Thank you, William. Jay, would you like to add anything?
No, I think William covered everything. I completely agree with that. This is a process, and we are at a stage where we have learned quite a bit from the past, and we will keep learning and it will keep evolving. Uh, the key reason being that we cannot foresee the challenges. Just 10 years ago, if you asked me about the data challenges that we're dealing with now, I would have no idea. So things have changed quite significantly in past 10 years and will keep changing. And therefore the challenges will be very different in nature and solutions will evolve.
All right. Thank you, Jay. Thank you, William. Do we have some time for one last question? The last one just
Yep.
popped up on
We have
here.
right in time, about a minute or so. Yeah.
So the last question is that how seamless would this product be in handling migration from on-prem data warehouse to a cloud one?
So I'm happy to take this one. So our product is actually agnostic to the choice of the platform and the location as well. So if you choose to build the entire model, entire solution, by the way, and you can take the same solution and deploy it in Snowflake in cloud, or you can take this thing and have it on SQL Server on premise. So it is that agnostic to the underlying platform. And we did it on purpose because we knew that this is actually something that is going to be of importance to a lot of organizations where priorities change. Sometimes you don't want to be on this platform, or you want to have two platforms, multiple platforms, and you should be able to adapt. You should be able to change, and therefore the whole modeling all the way to building a solution, this whole metadata based solution is agnostic to the underlying mechanism. And we generate, of course, the code generation is going to be specific to your platform, but all what you need to do is you build the solution and point to, let's say, Snowflake or Redshift or whatever platform you choose. We will be automatically adapting to that and generating code for that platform.
Thank you, Jay and William, for answering the questions. That was some great discussion. For anyone who still wants to find more about the topic, you can go to astera.com/resources, and we have some great white papers and blogs on data warehousing and automation. And if you missed something and want to rewatch, we will be posting the full webinar on astera.com/webinar. William and Jay, any last words?
Good luck with it all. Go forward and conquer.
Absolutely. Thank you, everyone. It's been a pleasure being here and answering these questions. I hope that the demo was meaningful and you were able to see what we have been able to accomplish with this product and what we have done for our customers. More than happy to work with you. If you have any initiatives where where you think we can work together, let us know. Reach out to us. We'll be more than happy to work on a solution that is specific to your needs. Thank you again for being with us.
Great. Thank you, everyone, for joining in. Enjoy the rest of your day.